Okay, and we're live. Well, hello everybody. Hopefully this will help you to look over or review some of the questions from homework 2-3. I'm going to be doing number 5 right now, and this is my first recording. So if it comes across as at all unpolished, that's why. So hopefully, there's my little pen menu right there. Hopefully the point will get across, and it'll help prepare you for the homework quiz tomorrow. In number 5, it says, assume that the brakes in your car create a constant deceleration of 4.2 meters per second, regardless of how fast you're driving. So that means that our acceleration is actually a deceleration, or that it's a negative acceleration of 4.2 meters per second. So that's how much our brakes slow us down, regardless of how fast we're driving. And there's two scenarios here. There's you're driving at 16 meters per second, so VI1 equals 16 meters per second. And we say VI because you're initially driving at 16 meters per second. And then the second scenario is VI2, at which you are at 32 meters per second. And the question is, if the speed is doubled, does that mean your stopping time is doubled as well? And that's what we're going to find out. Well, we have our acceleration, we have our VI in both instances, and so the question is, what's our VF, what's our final velocity in 1 and in 2, VF1 and VF2? Well, if our brakes work correctly, we have brakes that bring us to a complete stop. So our final velocity is 0 meters per second and 0 meters per second. So the question is, how long does 16 meters per second take us to stop versus 32 meters per second, and how do they compare to each other? So the t, that is the change in time, 1 is, we don't know that yet, and the change in time 2, we don't know that yet either, but we're going to find that out. So for 1 right here, we'll recall that acceleration equals the change in velocity over the change in time. We do have a velocity change, and that is the difference between 16 meters per second and 0 meters per second. And then we have all that over the amount of time it takes. Well, we don't know what that is quite just yet. I should back up, actually, because excuse me there. I should back up. I should just write it all out. So I'm not going to put numbers in quite just yet. So VF minus VI over delta t. Well, delta t right here, that's what we're trying to solve for. So we'll just rearrange it. We'll bring the delta t up, and we'll bring the a down to the denominator. So it's, when we solve for delta t in either instance, it's VF minus VI over our acceleration. So in instance 1, where we're driving at 16 meters per second, our delta t is 16 meters per second minus 0 meters per second, all over our acceleration. I did that wrong. What did I do wrong here? I got these two backwards, right? Yeah, I put them in the wrong order. So it's actually 0 meters per second minus 16 meters per second. And what that will do is that will give us a negative velocity. Well, it's okay because our acceleration also is negative. Our acceleration is negative 4.2 meters per second squared. If we calculate that all out, delta t1 is, and I should pause. Okay, our delta t1 should be 3.8 seconds. That's the amount of time it takes for us to slow from 16 meters per second to 0 meters per second if we are decelerating at 4.2 meters per second, or if we are accelerating at negative 4.2 meters per second. A negative acceleration and a deceleration mean the same thing. Well, if we apply this now to our second scenario right here, our delta t, it's delta t1, this is delta t2, is the same thing as above. Our final velocity is the same. We want it to stop at 0. Our initial velocity is what's going to be different. So this is going to be 16 in scenario 1. In scenario 2, we're going to be subtracting 32 meters per second. And we're still decelerating, or we are negatively accelerating at 4.2 meters per second squared. When we calculate all that out, our T2 comes out to 7.6 seconds. So indeed, it takes twice as long to stop if we are going twice the speed. That is number 5 in acceleration homework 2.3.